Hello everyone, this is Dwayne Kellum. I'm making this video because a couple of weeks ago, Jeran uploaded a video challenging the fact that photos of circular star trails around Polaris couldn't be made on a spinning globe. He had set up an experiment or a model and he tried to do it several times before uploading his video. He got a response from his challenge from Wolfy 6020 showing indeed you could get a circular star trail around Polaris on a spinning globe. Jeran acknowledged to Wolfie that he was correct and then took down his video. But Wolfie's answer left me with more questions than answers. I'm going to play Wolfie's answer to Jeran's challenge and then I'm going to tell you the problems I have with it.
So for the laser part of the demonstration, I've got this Skywatcher Star Discovery mount and I've located a laser right at the rotational point. I've just secured it there with plasticine, and as you can see it's just exactly at the point of rotation. So when that laser is on, it will illuminate a spot on the ceiling, and I'll demonstrate that shortly. And what I've also got is my iPhone with a second laser just attached to the top, and you can turn it on and off with the app, and that will also be located in the same position. Now what we then do is we align the phone at a slight angle. Now that's simulating how it would be positioned if it was on an Earth. Now we're not 5 years old, we don't need to see a blue ball here. We can visualize the geometry of the Earth quite accurately like that. So the rotational axis of the Earth is straight up that beam of laser at the center, and this one is reflecting the position of a person on the Earth's surface, which would be curved like that, and somebody looking towards Polaris. Now depending upon your latitude, you'll be looking high or low in the sky. So that's what this is simulating. So we are effectively simulating the geometry of a person on the globe looking at Polaris in this situation. So I'll just fire up the lasers and I'll show you how it works and how they do actually remain co-located. The problem with Jeran's experiment was that he has not aligned the string with the true rotational axis of the Earth, and also he does not have his laser aligned perfectly north and south. So both of those errors combine to cause that laser dot to move when he rotated the Earth. But as you'll see, when it's done precisely, it will line up perfectly. Now the key to making this demonstration work is the accuracy of the setup. You can see the care I have gone to there to ensure that the string is actually aligned with the rotational axis of the Earth. And you'll see the string extends up to that fire extinguisher nozzle on the ceiling, and we have the 23.4 degrees tilt. Now the second part of the alignment is how accurately we align the laser itself. You can see that I've got the laser positioned in the northern hemisphere, roughly around California, and it is pointing up towards Polaris, and it is aligned perfectly north-south. Now that's key to making the experiment work.
Okay, he said it was key to have everything aligned correctly to get the desired results. But I would say that alignment is key in order to get the circular star trails around Polaris on a spinning globe with a camera that is represented by this laser. It would have to be aligned perfectly to get the desired results. Based on what he just said, the shot that would be achieved would have Polaris in the center of the picture with the circular star trail going around it. Or it could be, it depending on the latitude or the longitude, it could be a half circle or a 3/4 of a circle, but the circle would be center in the frame. It couldn't come out any other way, because if the camera is turned just the slightest, it will throw off the alignment. So the alignment, as he said, is key. So I'm going to show you some stuff in a few minutes. Before I sat down to do this video, I tried doing the experiment myself. I just wanted to make sure that what I was thinking was the actual facts. So I had a globe that I had just lying around the house, and I got online and I ordered myself two lasers, and I got me some clay, and I put together a little experiment. And it took me 2 days to get those lasers aligned up so where they would be even close to staying together when the globe was spinning. And so I know that it is extremely hard and difficult to get those two lasers to align up and stay aligned when the earth is spinning. Okay, now the laser is representative of the camera that you'll be using when you set up your shot for the star trails. Now keep that in mind. In order to get the circular pattern that you see around Polaris, the alignment has to be correct. And so if the alignment is off just a little bit, the camera would diverge and your shot would not be a circle. It would be either egg shape or spiral or some other shape, but it would not be a circle. Okay, so I decided to do a little experiment, and this involved me taking two exposures over two different nights on the roof of my house. On the first night, I got my tripod and my camera, and I pointed it towards the north. I just eyeballed it. I didn't use a compass. I didn't use any kind of computerized software or anything. I just kind of eyeballed it dead north of my house towards Polaris. And I did my exposure. I did the exposure over a 3 hour period, and I'm going to show y'all the results. But before I do that, the second night I did the picture from the same location, but I turned the camera to the northwest slightly. And the second picture definitely should be off from the first picture. It should not be a circle, it should be a divergence of a circle if we are on a spinning globe. If we are not on a spinning globe, it wouldn't matter one bit. Both pictures would be a circle. They wouldn't matter because the earth is not moving, and so therefore the camera is not moving. And all it's doing is taking a picture of some stars above it that are rotating themselves. So, based on the two pictures I took, I came to the determination that the earth is still, it's stationary, it's not moving. And here are my results. Okay, so here's my first shot. As you can see, Polaris is in the center. The stars trails are traveling around it 360 degrees, perfect circle. Okay, this is the second night. I had my camera facing northwest. The alignment was off by a long ways. As you can see on this picture, Polaris is centered to the northeast. My camera is pointing to the northwest. With the camera being this far out of alignment on a spinning globe, the trails would be anything but a circle. It would be oblong, it would be spirals, it would be jagged, it would be uh, uh, a pattern like yin and yang. It would not be perfect circles like it was on the first picture when the camera was centered. So this is the proof that I need to know that the camera was sitting on a surface which was still, stationary, and not moving. The movement in this picture was made by the stars that circle the camera. The earth is not spinning 1,000 miles per hour.